There is one that is a very important one, something like g of y equals y minus 1 to the fourth over y squared, let's say y plus 2 to the fifth. So we're asked to find g prime of u. So this is a little bit messy because I have to be very careful. I have to apply the power rule combined with the chain rule. Then I also have to apply the quotient rule. So I have to keep in mind a lot of steps or apply different rules, right? So it's the quotient rule, so the denominator will be y plus 2 to which power?
Squared.
Perfect. Now we have to differentiate the top. I bring down 4. I subtract 1 from the power. And luckily, times the inner function prime, but what is the inner function prime?
1.
That's it. So I have to multiply by the denominator minus the numerator times the denominator prime. We bring 5 in front. We subtract 1 from the power. And luckily, again, the inner function prime should follow here. How much? Anyone?
1.
1. So I know it's tempting. I say it because every time, I shouldn't say every time, but every now and then I do see it. Some of my students simplify this with this and they say 5 are gone. No, you cannot do that. So please don't do it. What is the common factor in the numerator? The greatest common factor in the numerator.
Y plus 2.
I see y plus 1 in both. I meant y minus 1 in both. I see y plus 2 in both. Which power?
The third and the fourth.
The smallest of the two. Very good. The third it is, and the fourth it is. The smallest power for y minus 1 is indeed 3. The smallest power for y plus 2 is indeed 4. And now the denominator. Do not look at it just yet. Now, so what is left from the first term? These 3 are out. 4 out of 5 are out. So there is still 1 in there left over with a 4. So can anyone tell us what to write here?
Four y to 8.
4y plus 8. Or parentheses. I accept both. 4y plus 8, or you put 4 parentheses y plus 2. We reach the negative sign. Y plus 2 to the fourth power are all out. From these 4, we took 3 out, but there is still 1 left in. And the 5, and the minus. So I have a y minus 1 times 5 with minus in front. Can anyone tell us what to write here?
Five y minus 5.
If you put parentheses, right? So 5 times y with minus is 5y. 5 times negative 1 is negative 5 times minus 1. Is this okay? And now, yes, absolutely. Because we are simplifying factors. We cannot touch terms or pieces of terms. So the final simplified form So the equal symbol is y minus 1 to the third, 4y minus 5y, negative y, and 8 plus 5 is 13, over y plus 2 to the 6th power. This is what we need. Basically, with negative in front, y minus 13, y minus 1 to the third, over y plus 2 to the 6th. You could say that I'm allergic to negative leading coefficients, and I want this simplified form. Careful. I saw in your work you are multiplying or distributing the factors in the denominator. Please do not expand the factors in the denominator. So if you have a denominator like this, please do not waste your time. We don't need it. Actually, we want the opposite. So I saw some of you wrote something like this. Let's say x plus 1 squared, and then they wrote x minus 1 over x squared plus 2x plus 1. We do not want this. Specifically, we do not want this. No, we want this. So please do not expand the factors in the denominator. Please don't. Waste of time, and this is what we need, because this is useless. Here I can tell you that x cannot be negative 1, but here I have to factor to tell you that x cannot be negative 1. So we do not want this. We want this. Okay. Is this clear? All steps? Everyone?
Chris, can you show the first step again?
Say it again.
First step.
You want me to explain, or you just wanted to see it?
No, so explain.
You mean from here?
Yes.
It's the quotient rule. 1 over 2 prime. 1 prime times 2 minus 1 times 2 prime over 2 squared. So the derivative of this is this times the denominator, and then minus the top times the denominator prime over the denominator squared.
Okay.
So we used this rule. We brought 10 down, we subtracted 1 from the power, and we differentiated the inner function. Luckily, the inner function was 1. But we used the power rule combined with the chain rule. Is this okay, everyone? Any questions? Is it okay if I ask you to upload this? Just 1 page. I will change. I know I have lowercase in there for March. My apologies. I just typed it quickly because I forgot to put it in. And then I would like to talk about, by comparison, e to the x and a to the x. And of course, e to a function and a to a function, prime. And then I'd like to look at some applications. Let me know if you need more time. Are we okay? Can we continue? Let me know if you need more time. Can we continue, everyone?
Yeah.
Okay, I'm going to share my screen to look at a problem in the book. So I'm looking at something like this, or this, or this. So by a twice differentiable function, it means that the first derivative and the second derivative both exist. So let's look at 77. Let's say r of x equals a function f of g of h of x. 1, 2, 3, correct? And we're given that h of 1 is 2, g of 2 is 3, h prime of 1 is 4, g prime of 2 is 5, f prime of 3 is 6, and they want r prime of 1. So all this is less important because we know how to plug in numbers. But how do I differentiate this? Remember, outer, so this is number 1, this is number 2, and this is number 3. So r prime of x will be f of everything, of course prime, times g prime of everything that is left in times h prime of x. Do not break it down like that. I wrote in the way. So this goes on as a chain. F prime of everything times g prime of everything times h prime of x. So if I want to determine now r prime of 1, I have f prime of g of h of 1 times g prime of h of 1 times h prime of 1. So let's start with the easiest, 4. Then I have to start from the inside, always from the inside when we evaluate, from the outside to the innermost when we differentiate, but from the inner to the outer when we evaluate. So h of 1 is 2. But now how much is g prime of 2? G prime of 2 is 5. So what I have right now is 5 times 4. Everything else is gone. Let's look again. H prime of 1 is 4. I have to start from the inner. H of 1 is 2. So if this is 2, now I know I want g prime of 2. But g prime of 2 is 5. So these two are simply 5 times 4. Let's see here. Again, I have to start by evaluating from the inner. 2. G of 2 is 3. F prime of 3. F prime of 3 is 6. So all I have is this times this times this. Of course, I'm going to do 5 times 4, which is 20, 20 times 6, which is 120. Or you can say 6 times 5, which is 30 times 4 is 120. So please remember this concept. Of course, when we evaluate, we have to evaluate from the inner to the outer. Now, coming back to what I wanted to say a minute ago.